Let's shift our attention to polygons. Children begin learning about shapes very early in school. Starting in kindergarten, children describe objects in their environment using names of shapes. In first grade, they begin to draw and reason about shapes using their defining attributes. For example, they may say a square has 4 sides. In second grade, children start to identify more complex polygonal shapes, such as pentagons and hexagons, by name. This lesson focuses on defining polygons and classifying them by defining attributes. So, what is a polygon? Let's begin by looking at examples and non-examples. Here I have several examples and several non-examples. If I look at the example sides, I see a square, a hexagon, a pentagon, a triangle, this kind of weird quadrilateral in the upper left, and this arrow. That arrow shape is important because it reminds us that polygons do not have to look regular or familiar. They just have to meet the definition. For my non-examples, I have a circle, I have a cube, a cylinder, this weird shape with round curvy edges, this shape that doesn't fully close, and this shape with these edges that intersect. So why are the shapes in the first list polygons, but not the shapes in the second list? A polygon needs 4 defining characteristics. The first is that it needs to be closed. Closed means the shape must come all the way around and connect back to itself. This one right here is not closed. The next thing it needs to be made from straight edges. And this is going to eliminate a few. It'll eliminate our circle as well as this weird shape here. Technically, it should eliminate this cylinder as well, and it does, but I'm going to wait on that one for just a second. The next is non-intersecting. Non-intersecting means the edges do not cross each other. That'll get rid of this option here. And finally, it needs to be 2-dimensional. It needs to be flat, not a 3-dimensional object like a cube or a cylinder. So with that, we can give a formal definition. A polygon is a closed 2-dimensional shape made from straight, non-intersecting line segments. That definition is powerful because it helps students move beyond appearance. For example, some children may think this arrow is not a polygon because it looks unusual. Others may think a circle is a polygon because it is closed. This is why definitions matter. As teachers, we want students to learn that in geometry, categories are based on defining attributes, not just on what looks familiar. One useful classroom move is to give both examples and non-examples and ask, what makes these different? That kind of comparison helps students build stronger concept images and stronger definitions. And that's exactly what we want. You don't need to memorize every possible shape. What matters most is learning to ask, is it closed? Is it flat? Is it made of straight line segments? And do the edges avoid intersecting? That is mathematical thinking.